Hello, today's lesson is slope fields. And what we're trying to do is solve differential equations. Okay, a differential equation, it means it has a derivative in it. So if I am given the fact that my derivative is equal to 2x plus 3, and my goal is to solve it, is to find the function, the original function, I know that I can integrate 2x plus 3 with respect to x, and I end up with x squared plus 3x plus c. And I have the original function. And if they give me a point, we can find the particular solution. Okay? The problem being is you're going to get a derivative, like our first example down here is x minus y. And I can't integrate x minus y with respect to x because there's a y in there. Okay, if I do a u sub, I'm still got a y in there, and it's things I don't have, all right? But I want to know the parent function. So what I'm going to do is make a slope field, which is a graphical approach to help me figure out what the parent function is. There's always one of these on the AP exam, because from the slope field you can get to the parent function. From the parent function you can answer an application problem. All right? So it's easy to have a multiple step problem. All right, so your goal is to get dy dx by itself. So here's my dy dx all by itself. And create a table if necessary. And find out how many points fill those places in. So if these are the x values, okay, those are the x's, these are the y's. If the x is 0 in this situation, your answer is a negative y, right? So I got negative 2, negative 1, 0, 1, 2. If y is 0, it's just going to be the x value. All right? So what I go and do is, here's all the places that x is 0. Add 2, my slope is negative 2, so I'm going to make a little line. The slope looks like it's negative 2. At 1, it's negative 1, which is 45-degree line. Here it's 0. Here it's positive 1. And here it's positive 2, so make it a little bit steeper. And they're just little lines, and remember that it's tangent. These lines are tangent to the parent graph. All right, when I go across, when y is 0, over here, this one is negative 2, and negative 1, and 0, and positive 1, and positive 2. And now I need a few more. So these always mess up my poor little brain. I have negative 2 minus 2, so this is negative 4. I have negative 1 minus 2 is negative 3. 1 minus 2 is negative 1, and 2 minus 2 is 0. So when I go across, when y is equal to 2, over here is 0. This one's negative 1. That was negative 2 we already got. Negative 3 is a little steeper. Negative 4 is a little steeper than that. Okay? You come in here, and you have negative 2 minus 1 is negative 3, negative 2, 0, and 1. So across here, this one's got a slope of 1, 0, negative 1, negative 2, negative 3. Come down here, negative 2 minus a negative 1, so this is negative 1, 0, 1, 2, 3. So this is negative 1, 0, 1, 2. Did I miss something? No, that was 1. This is 2. This is 3. And now this is 0, 1, 2, 2, 3, 4. So here's 0. So this is straight. This one should be like that. And then I have 1, 2, 3, and 4. Okay, so it sure looks like if I was going to come through here and graph the function, let's say it's going to come down here. It's tangent to that. It's tangent to that. It's tangent to these. Okay, so here goes my graph, like that. And that's a graph of my parent function. Okay. Same thing. If you start with the zeros, if x is 0, this is all 0, so these are all lines like this. And if y is 0, it's undefined. Well, how do you graph a line that has an undefined slope? It's vertical, right? So I think that's what they're telling us right here. If x is 0, you have horizontal. And if y is 0, you have vertical. All right, now let's say x is 1. So I have 1 over 3, so that's 1/3, 1/2, 1. And now one of them is negative, so this is -1, -1/2, -1/3. All right. Well, if you have these all the same, 2 over 2 is 1, so that's a slope of 1. That's a slope of 1. They're both negative here, so it's negative. They're both still positive 1s. This is going to be -1. Okay. Gives me a couple good ideas. So let's do these guys. If I have x is -1 over 2, it's -1/2. Oop, like that. And this would be -1/3, so it's a little flatter. Here I have -1, -2, so it's a positive 1/2. A positive 1/3. So it looks like I've got a graph that's doing this. Sort of looks like a hyperbola. Okay. So that's all there is to this. Just need to make those little lines. To me, it's just a pain in the neck. Okay. All right. X is 0. X is 0, so these are all -1. Every single one of them. Okay. If x is 1, these are all 0. If x is 2, these are all positive 1. X is 3, these are all positive 2. X is -1, so these are -2. Right? And what you see is that your graph is going to be coming down here. And you'll notice there's all in the same spot. That's where the plus c comes in. Which one particular solution to that problem? This one we could have integrated, right? If I integrate x minus 1 dx, you get x squared over 2 minus x. Sure, it looks like a parabola. Okay? So I could do that one. This one's got an x and y in it, so I don't know what to do. So here we go. If x is 0, it's undefined, so these are vertical lines. If y is 0, it's 0. If they're both the same, it's 1. One's positive and one's negative. They're both negative. They're both positive. All right, and you need to put in a couple more. So if I go over here, you have 2 over 1, so that's 2. 3 over 1 is 3. I have 1 over 2 is a half. I have 3 over 2. It's a little bit steeper. All right. I have 1 over 3. I have 2 over 3. This was 1. Okay, go back over here. You have 2 over -1, so it's -2. Did I do these right? 2 over 2. 1 over 2, yeah. So what's this one? I have 3 over -1, so it's -3. Go here. You have 1 over -2. -2 over -2. -3 over -2. All right. And you continue that way to make your slope field. Okay. Construct a slope field for the differential equation and sketch the graph for the particular solution that goes through that. All right. So if x is 0, it's whatever the y value is. So y is 1. Here it's 2. Here it's 3. If we do this one, this is 1, 2, 3, negative 1, negative 2, negative 3. This is same thing, negative 1, negative 2, negative 3. All right, plug in this. 1 and 1 is 2. 1 and 2 is 3. 1 and 3 is 4. Here we are. 2 and 1 is 3. 2 and 2 is 4. What's about over here? I have negative 1 and 2 is 1. Negative 1 and 2 is 1. What did I do wrong here? Negative 1 and 1, so this should have been 0. All right. So down here, these should all be zeros. What about this point right here? Because it looks like one I'm going to need to know, because I'm talking about going through that point right there. Oh, that point right there. So let's do this one. You have x is 1, y is negative 2, 1 is negative 1. Okay, well, I don't know. Maybe it came through this way. So I'm supposed to sketch it. It's coming through like this. It's going across this. All right. What's that one do? You have x is negative 2 and y is 1, so this is negative 1. So my slope is like that. So it must be coming through here like that. And it's taking a turn here. We don't know what the graph is. I'll have to find out. All right, you could have used a chart. I just like to do my x's are 0, my y's are 0. They both have the same value. It makes an easy start. All right. Now, here's a slope field for a differential equation. Which of the following could be a specific solution? Okay. Well, if you remember, these are tangent to the curve. So the curve's got to be going like this. Okay. And then it's tangent here and here. What's that look like? What shape is that for the parent graph? Looks like an x cubed. Okay. Same thing here. Slope field's given. Specific solution. Well, it looks like it's coming along this way. Goes up like that. What kind of graph is that? Natural log graph? This could be a natural log graph going this way. So my guess is this one. It's not, right? If I differentiate this, you're getting an x squared. If this was the graph, okay. So your assignment is to practice drawing slope fields. Hope that made sense. And the goal, remember, is to find the parent function.